Hello everyone, we are Team Nexus. We are excited to share with you today our experience with Spark. So what is Spark? Spark is a distributed processing solution and it consists of a variety of components that provide it with substantial functionality and performance over other distributed systems. As an example, Spark has four major components: the Spark SQL, the streaming, the MLlib, and the GraphicX, which provides the different functionalities. And then let's have a brief history of Spark. Spark is developed in the 2009 as a sub-project of Hadoop at UC Berkeley. The original goal is to extend the MapReduce model, which is originally developed by Google. It then quickly became open sourced and donated to Apache, where it gained substantial support and growth from the development community. Today, there are thousands of companies using Spark for their core product. So it comes to our first question: why do we choose Spark for the project? First, the number one reason is the speed. Spark leverages in-memory computing to improve the performance and efficiency, making it 10 times to 100 times faster than running an app on a Hadoop cluster. The second reason is the extensibility. It has built-in support for multiple high-level programming languages along with an interactive shell. Also, as we mentioned before, Spark has substantial support from the open source community, and it includes companies which invest billions of dollars into the development and the deployment of Spark. You can find many startups with the business solely depend on Spark. As a result of this, the number of libraries continue to grow and the new functionalities continue to grow. So we feel like it is very good experience for all of the students to know Spark, to practice Spark, and have some knowledge of it, which should be good for our future careers. Now we come to the Spark setup tutorial for the Linux system. These steps are not difficult. We just need to be careful to do the right thing at the right sequence. The first step, we need to verify that the JDK is installed. We can either check the Java version and the Java-C version. The second step, we need to install the Spark. This is fairly straightforward. We just need to go to the right address and download and unzip the file. The second step, we need to install optional project packages, including Hadoop if we want to use the distributed clusters, or Scala and R if we want to use those language. If you want to build with Java, you will need to install Maven, which we will mention later in the slides for our demo task. The last but not the least, it's better for us to verify that installation is correct before we actually go and do any coding. So we feel like it is better for us to add the right path to our batch profile for all the necessary components. Here I have a list of the suggested paths, including Spark, Maven, Java, Hadoop, Scala. And we need to restart our batch profile and test with the interactive shell. Now let's look at the demo task. The first task is about the human resource analysis. Our motivations are this. We have the feeling that most of the daily work and daily tasks are not overly complex, which only require simple tallying and summarization of data or retrieval and modification. The datasets we will be using is the HR employee records, which has 15K entries. In the slides, I'm showing only a few of them, just for you to have a feeling. And each row here represents one employee. And to note that all of these employee records are from those people who resigned from their company. Each row represents one employee. Each column represents one attribute. We need to notice that the very first column represents the satisfaction factor, and the last column represents their salary, which is marked by low, medium, and high. The example I'm showing here has only low, medium, but in the actual data sets, as I will show later, has also high salary. The first task for us is the basic operations. The motivation is for us to use Spark with Java, And we want to familiarize ourselves with Spark functions and importing data from a CSV file. The task is fairly straightforward. We will count the number of employees with the low, medium, and high salaries respectively. And we will output them into the output file. This is the Java file that we use to do the actual processing. The function, we need to import the correct function and load the data, count the number of high, low, and medium employees, and output them. It's fairly straightforward. To build this file, we need to use a Maven to build the file. And the dependency we need to add is a dependency on Spark. We need to add a few lines of section here in the Maven file. And this is the output, which shows the number of people with low wage, the number of people with medium wage, and the number of people with high wage.
As you just saw a simple implementation of can use Spark. Now we are going to learn to work with one of the main modules of Spark called Spark SQL. Spark SQL is a Spark module for structured data processing. Internally, Spark SQL uses this extra information to perform extra optimizations. There are several ways to interact with Spark SQL, including SQL and the dataset API. So here we are going to load our data into Spark data frames and then perform SQL querying on that. The main objective is to query the CSV file as a data frame and implement the manipulations using various domain specific language functions, and implement SQL queries to query the data frame as a relational database. So to implement this Spark SQL querying, we would first have to load our CSV file into our data frame by reading each line and converting it into a table row format. So, and also we are using SpySpark. So we are implementing this in Python and not in Java. So here we are loading our data into CSV format and taking the header as true so that we can define schema as a first row as the name of the columns. And then we are loading the CSV files. And now we will be implementing various data frame operations like select, filter, group by, describe, count, and describe would display various statistics such as mean, standard deviation, max, and min. So here we can see how we are using df.select, which would display the all the satisfaction level column values, and here we are subsetting the data using filter for number of projects which are greater than 3, and here we are filtering the database based on department technical and then describing or showing statistics for that department, and the output for that would be so here is the output file, and so here we can see the first 20 rows for the CSV file, and this is the schema for our data frame. It is displayed in a tree format, and here like here we can see the statistics for the technical department such as count, mean, standard deviation, min, and max, and here we can see the count of people by the department. And then we would register the data frame as a SQL temporary view, and that would create a view such as similar to in MySQL, and then we can implement various SQL functions such as group by and calculate average on the temporary SQL view. So here we would calculate average of number of projects for each department. So for that we would like, so here this is how view, and here we are writing a SQL query directly on the data frame. So select average number of projects and department from HR people and group by department. So this would give the output similar to this. So this is here the department and department wise averages of the number of projects. So this is basically how you can use Spark SQL and implement SQL queries directly on a data frame. And other applications for using Spark would be data streaming, such as streaming Twitter data to do some analysis on the tweets, or using mlib to perform machine learning using their pipelining, or also to do some interactive analysis such as visualizations or dashboards, or working with distributed datasets and doing data integration and data processing, parallel distribution, fuzzy matching. and also you can work with machine generated data such as genomics data. Thank you.